Hello everyone, welcome to the Byte Nexus Tech. So in this previous video we learned what Linux is, why Linux is called a kernel and why Linux used everywhere. If you have not watched that video yet, I recommend watching it first because this video is continuous from there. So now in this video we will understand how Linux works internally step by step and what happens when you open an application and Linux architecture and the Linux distributions. So let's begin. So guys, as we know, when we click on the Chrome, within a second we'll see window gets opened and CPU works, RAM gets used, file load and mouse also responds, right? So but how? Who coordinates all this? That hidden manager is called a Linux. So today we will understand inside the system and we will see how the flow works, how internally kernel handles everything. Okay, so this is the flow which we have for the system. So in this first we have a user. User means the person who is using the system, right? And next we have a application. Application is like a browser, apps, music player, etc. Right? Editor. So next we have a Linux kernel. So Linux kernel is a manager of the system. Then we have a hardware which is physical device, right? So guys, here the important rule, right? User cannot directly talk to the CPU or a Chrome cannot directly control over the RAM. So everything will goes through the kernel. So this protects our system, right? So we'll understand what happens when we open any applications, how the flow works, how internally it works. So we'll understand it through one example like Chrome. Okay, when we open the Chrome, how the flow works. So first is when you click on the Chrome. Okay, let's say you clicked the Chrome using mouse or a keyboard touch. So how this works is, let's say finger click. Okay, so when you click on that touch keyboard, then there is a touch driver inside that which calls kernel. Okay, then here driver tells kernel user click here, then kernel checks which icon clicked and which program path it is, and each that app installed in the sense it has to be present in user pin directory. Let's say here we have Google Chrome. Okay, then kernel starts processing it. So here you can see, so here next Linux kernel will creates the process. Okay, it will creates process. So guys, process means it's like a running the instance of the program. So let's say I will give example like file chrome file. There will be files which is related to Chrome which is will be stored in a hard disk, right? So that we call it as a program. So when we open this chrome opened now, you clicked and Chrome opened, this we call it as a process. So for each process kernel will allocate the process IDs, right? There will be unique process ID for each process. Okay, let's say kernel gives process ID to this as 2451. Okay, so next we have a memory allocation. So now Chrome needs RAM, right, for running the things. So the RAM will allocated by kernel. Kernel will decide how much RAM to give. So let's say it will have it will check like Chrome code and images, tabs, data, etc. Based on that, it will allocate the RAM to this Chrome. Okay. Now next and the most important thing is CPU scheduling. So guys, here as we know, at a time we are not running only one program. Like let's say you are opening Chrome, it's not like that you are only Chrome is opened in your phone. In the background, let's say WhatsApp will be opened and some system UIs or some recording things, etc. Right? So how CPU manages this all API, all these apps in a single time, right? So then here we have a concept called scheduler. So here what this scheduler does is, let's say there is a app 1 opened, app 2, 3, 4. So that the CPU time will be split between these apps. Okay, 10 millisecond will be here, 20 millisecond will be here. So this scheduling things, how much time to for the each apps get, that will be decided by the kernel. So guys, so this will be very fast, so that we will not get to know like this app is now currently used or is something. So it will be very fast. Okay. So next is file loading. So as we know, as we seen here, the Chrome files are stored in a disk. So when we open the Chrome, then what happens is, from the hard disk, it will reads and it will read the files from hard disk and it will write to RAM. Then it will start running from the RAM. Okay. So finally we will be having window display, which means Chrome data, whatever we got, that will uses display system, then it will finally into screen, right? So now you see the browser, right? So guys, see, opening one app means many systems works together: input system, kernel, CPU, RAM, storage, display. So here what the kernel is really doing. So so we will see what kernel duties here. So kernel first main duty is like process manager. So process manager means starts and stops the apps. Then we have a memory manager which allocates the RAM. Then we have a CPU scheduler, that means which which gives the CPU turns for the each apps. Then we have a file manager for reading and writing, right? Then we have a device drivers which talks to the hardware, like example, talks to keyboard, mouse, speaker, etc. Then it has a security to prevent illegal access. So these are the kernel duties. So guys, next we will understand how this Linux divided into. So Linux divided into two parts. One is user space and the kernel space. So user space is like normal apps will be running here, like Chrome, VLC, which is not having directly control over the hardware, cannot directly control the hardware. And we have a kernel space. This is the privileged, sorry guys, privileged core code runs here. and it can access the hardware. So why we need this design? Because let's say if app crashes, okay, so if app crashes, then system will become chaos, right? Like if every app controlled hardware directly, there will be system will be in complex, right? So that's why it is divided like this. So now we will understand, then it is divided like this means how this user space and control kernel space will interact. So this is through system calls. So guys, about system calls we will learn in our upcoming videos thoroughly, but I will give some brief idea about the system calls. So system calls is like how apps talk to the kernel. So examples we have like there is open system call, and then read, write, fork, then execute. Right. So when Chrome app clicked here, it has to go through with system call, then it comes to kernel. Okay, we'll see one example like when you want to open a particular uh, page from the Chrome, right? So then Chrome will call open system call, then it will goes to kernel and it refers to hard disk for that particular, right? So guys, here we have to understand why Linux is this much fast and stable, because kernel controls everything here in like a manager centrally. So which is like it has a benefits like better scheduling, better memory use, safer access, multitasking, stability, etc. So guys, I hope you understood about this kernel and how it manages the things, right? So next we will understand the distributions. Okay, as we seen in the last video, like kernel alone is not enough, right? It needs apps, tools, installer, package managers. So it needs a full package. So that full package we call it as a distribution, right? Which we call it as OS also, right? So here we have like so many types. So let me give how it is distribution formed. Okay, it will be formed by kernel plus apps plus package manager plus tools, etc. So this we complete package formed one distribution, right? So first one we'll see Ubuntu. So Ubuntu is like for beginner wave. This is for beginner friendly. So if you are a beginner, you can, I think you can refer this Ubuntu, and then it is Debian is a stable one, stable OS. Then we have a Fedora which contains all latest features. Then we have a Arc which is custom designed, custom advanced. So guys, here you have to understand like let's say car. So car will have same engine but with different cars, which mean like different cars have same engine but the model will be different. It's so likewise kernel will be same but the model complete package contains different packages or as tools or etc. So I hope you understood the distributions. So guys, I would like to explain this what we learned, this complete internal flow, how complete system works. So guys, so first user clicks app. So user clicks the app, then it goes to input driver. It can be mouse, keyboard, touch, anything. Then kernel receives the request. Kernel receives the request. Then process gets created. Then it will allocate the RAM. Then keep you scheduled for that process. So guys, the CPU how scheduling works, this we will see in upcoming videos thoroughly. Then files gets loaded from hard disk to RAM, and then graphics will be drawn. Then we will see output on the screen. So guys, final summary. So today we learned Linux sits between apps and the hardware, and kernel manages CPU, RAM, files and the devices. Apps uses system calls, and Linux separates user space and the kernel space, and distributions are complete Linux system. Okay. So guys, now in the next video we will learn Linux file system.